Okay, so now we're doing basic LuCI development, building on what we've done so far with Lua. I'm going to start with an overview of what LuCI is. There are 9 modules here. They build on each other, and then I have some actual, I have a router actually plugged into this device. You can go to github.com/relationfoundation/LuCI_tutorials, or in that same secondary directory that I talked about earlier that I'm not going to say on the video because they won't be there next time if you don't have GitHub, to grab these. I would actually suggest going here even if you don't want the tutorials, because we do have a folder or a couple folders, one with some examples, as well as a folder with a debug script that is a pretty useful little debug script.
You're going to pull those down
later? Anyone can pull them down whenever they want if they find it useful, and we can talk about it, or we will talk about it today. But so LuCI is a model view controller bit of software. That means that LuCI uses the UCI configuration pages as a data model, which it then translates using the CBI system. And the CBI essentially acts as a view in this case. It is a scripting language that the model is pushed into to compile into HTML pages. And then it's run by a series of controllers, which are Lua scripts found within the LuCI directory. So the LuCI directory is contained at, well, let's start here first, actually. If you go to the LuCI tutorials file on GitHub, there's a make file there. If you go into that make file and run make on it, what it's going to do is it's going to, if you have the requirements, which are listed in the make file or on the internet, make you a local version of LuCI that you can run all these commands on and look at the file structure within. What I have here is in the make file, it also steals Dan's LuCI Commotion Linux package to copy over all the Commotion prettiness so that it actually looks like our LuCI and not the generic OpenWRT. So if you'd like, you can do that and you can follow along instead of having me just kind of talk at you about these things. I do have a router and I'll be going into it in later sessions to do some more in-depth digging. But for this first one, I'm not going to actually go into the directory structure to show you these things. I'm just going to assume that if you want to follow along, you are more than welcome to either jump on a router or load up the LuCI directory, which creates its own host file, which is essentially all the files you'd have on a machine under the directory hosts in that LuCI directory when you run the LuCI, like the LuCI development environment, which is what that is, which allows you to actually have like UCI files that you mock up and put in that mocked up host file and play with. So that make file is there for you to play with if you want to do some development right now or whenever. I highly recommend it. I run a LuCI virtual development environment in a virtual machine so I can access it from my computer.
And also the LuCI Commotion W packages that we have will also set you up with this too.
Oh, cool.
So
Should probably do that instead of my hastily built make file. I jumped all the way down to CBI. What we want is still here. The LuCI directory structure. LuCI is a set of Lua scripts that run that MVC. It's contained at user lib Lua LuCI. It also has some default directories, which are set in the UCI file, but they also have references that you can see in the templating code. One is resources, which is in www LuCI-static resources. These are non-theme specific resources. These are resources that are used by the entire LuCI system. Images, JavaScript, CSS, HTML assets. This has the OSRviz script in it. Then there is the media folder, which is in www LuCI-static Commotion, or whatever the theme's name is. Ours are in Commotion, and those are the theme-specific resources, so the current active themes resources. So when you're developing for LuCI, if you're extending LuCI itself, feel free to put resources in LuCI-static resources. For instance, maybe the updated UI stuff would go in resources because it's not theme-specific, it's just a package-specific, versus anything that's theme-based, which would go in the Commotion directory. And these are decisions you have to make, but the current standard is resources are LuCI generic resources, and media is theme-specific resources. Then there's the LuCI config file. It's a generic UCI, or not generic UCI file. It is a UCI file, as beautiful as they are. It has a bunch of components. The first section, core, which has the name main, basic settings, turning off the network interface unit, setting the language. Then there is extern flash keep. These are the files that are kept when sysupgrade is run with keep settings on. Now, mind you, there's more to that. These aren't just the files that are run when sysupgrade is run. There's some finickiness, and you can find most everything you need to know in this topic on the OpenWRT forum in order for modifying what files get kept when safe settings is clicked.
Sorry, where are these? Where's the config file?
LuCI UCI file. So the UCI etc config LuCI.
Oh, okay.
Sorry. There are internal languages which have the abbreviations and then the full language name in local character set, I should point out, for all the LuCI supported translatable languages. There's also internal SAuth, which is where the internal authorized sessions are stored when you log in to the LuCI interface and how long those last. So you can actually set, like, a session should last for this amount of time, so the sessions will reset at a longer or shorter period. Then internal Ccache. This is one of the realms of places where you can turn on and off types of caching. And debugging will go really, well, not really deep, but we'll talk about all the different ways that LuCI caches pages and modules and indexes. This one is where we actually cache modules code. So when you're doing code changes, but not index or page changes, this is the, when it's set to 1, it caches them. When it's set to 0, it no longer caches them. So this can be turned off for easier rapid development. And then this is, the last one is the section called, last one is an internal section named themes. And that one is all the themes that LuCI knows about. This is usually automatically updated. We shouldn't have to manipulate this by hand. But when doing development, if you want to add another theme, you don't want LuCI to go through all its rigmarole to find that theme, you can just do it right here so LuCI knows about that theme. Next. And again, this is just a quick overview. We'll go into depth on a lot of these things later. CBI models are the Lua files that describe the structure of a UCI config file, and then how to translate that into an HTML page. And so the main CBI parser, the thing that actually takes CBI files and makes them into the HTML files, is in userlib.lua LuCI cbi.lua. Also are the data types. Now the data types live in the folder CBI in the LuCI main directory under datatypes.lua, and these are actually the client-side JavaScript that checks the input values when you're using UCI files. So you can set data types in CBI, and so like the type is IP address, and it will, using the datatypes.lua file, add in the JavaScript to check to make sure it's a correct IP address. And again, we have a whole section, section 4, on CBI. We'll go into a lot of depth, but if you're ever receiving errors in these two files, data types or CBI, this is what those two files do. And that's the controller for all CBI. Now, the LuCI API can be found at this IP or this HTML address. It's the address. I've been talking too much. This is going to be really in-depth and concise, guys. Get ready for this. I've been talking for hours, by the way. You're only seeing the beginning of this. So this is the address you should go to if you want to look at the LuCI API. Now, the LuCI API are the helper functions built for the LuCI system. A ton can be done in LuCI with just the CBI system. The CBI system translates any UCI files into pages, and you can put functions in there, you can have buttons, you can have a lot of manipulation. But if the program you're trying to manipulate is not CBI, if it isn't UCI based, if you don't have, like for instance, Commotion uses its own Commotion profiles, CBI can't help us parsing Commotion profiles. It only knows UCI format and only deals with UCI files. You need to use the LuCI API in order to build yourself pages that can, you know, not use the CBI system. Go ahead. Sorry.
to derail anything, but why are your Commotion profiles not UCI files?
Well, they're in interim format right now that is compatible with the format that was originally laid out by Hans from Guardian for the Android application. And so that's why they're in the format that they're in. They're eventually intended to be JSON files. Like I'm writing a JSON parser into Commotion D so that they, but the format for those is meant to be cross-platform and not specific to the UCI system.
Okay. Oh, son of a gun. Ugh, it's my fault. So, now that everything's ruined, where's my mouse? Okay, so the LuCI helper functions are higher level, really useful sets of functions. We have a whole section on just that API, by the way, coming up. But underlying the LuCI functions is the network and I/O library for Lua called Nixio, and so that's a lower level code that powers the LuCI API. And these are like when you're trying to do a specific thing, like open an SSH session and the like. Nixio is where any sort of like I/O or networking stuff is actually usually written in, or is using the pre-existing Nixio functions. Because all of this can be rewritten in Lua, but the Nixio and LuCI APIs are really useful for taking and building your own systems for interacting with the node. Again, there is a LuCI development environment. The LuCI development environment can be run from the makefile provided in this repo, or you can go to that address in this this page and follow their instructions. They're just not a makefile, and it's a pretty simple process to get going. And then, so you should, a lot of the LuCI stuff is not necessarily generic learning. There's also a lot of just like snippets in this tutorial, I should point out. This one right here is how to execute a LuCI command from the Linux shell. -L is used to load a module. -E is used to execute some Lua script. So by doing Lua-L luci.sys. This is in the user lib Lua LuCI directory, by the way. And then -E, and then running a LuCI command, because luci.sys because LuCI, by the way, is the file .sys is within the LuCI file. We are running in the LuCI module, which would be a file on its own, the sys module and then sysinfo. And so each module itself will pull in modules that are around it, because most of them have package C all included. But just so if you ever want to see what the output of a function is on the command line, this is the command line version of running a LuCI command from the Linux shell. And then there's a config file for init scripts and dependencies. We'll talk about save versus save as a little bit later and why this exists. But when you change a config file using the CVI system, it checks against this config file. It says UNI track, it's UCI track. It checks against UCI track to see, and that's essentially a UCI file that lists all the UCI files in that folder and what init scripts have to be run in order for that to set correctly. So on the networking one, it says Wi-Fi and networking. So then it runs etc init networking and etc init Wi-Fi in the order given. In order, after you've committed a change to a file, LuCI does that in the background, so that it'll automatically restart or run stuff depending on what the needs are. And it's a really cool system because we can also add our own init scripts. If, let's say, anytime someone changes the networking page, we want to say we also want Commotion to be rerun, we can add it there, and a CBI file will call etc initd/Commotion and run that to check, in the order we give it for whatever files we care about. And they can do recursive dependencies and the like. It's pretty cool. Anyways, let's talk about the LuCI and Nixio APIs real quick. let me open these up right here, because if you're following along, you should open these up as well. To remove myself from this node, that would be helpful. So, huzzah, and huzzah. Okay, so first let's go through the files that are in userlib LuCI, and I'll just talk a little bit about them, and then I'll actually go into the, I should keep this unplugged because someone need to click on the links, and then I'll go into the actual APIs for them so you can see where you access the APIs to run these functions. So userlib LuCI, then there's a bunch of Lua files in that directory. These are the main modules that you'll be calling through the API. Some you won't actually really be calling, and I'll tell you what they are and what they're doing, but many you will. So all the asterisk functions live in the asterisk.lua file. I don't use asterisk. I don't really know what it does. I know there are people in this room who do, though. So
Like,
tell me about it.
The PDX server?
I think so.
Okay, well that's if you want to run like a, let's see, yeah, looks like it. Asterisk is a phone server, so that would be a
Yes.
VMI. Yeah, so that's if you wanted to use your OpenWRT device as a phone router.
Cool. So
yeah, we don't use that.
yeah, I've never used it, but I think I've heard the term. I'll say it. So that's what that does. Cache. So there's a few of these like just controller functions that live here. Cache loader is one. It runs the config.lua file, which looks for Lua, the UCI file, and parses the Lua UCI file. And then if that is there, and Ccache is set, it runs Ccache cache on demand, which essentially runs the basic debugging that we get when we error out on a Lua page. So when you're doing a LuCI page and you get that cool error, that's because cache loader checked the Lua UCI file and said, oh, I'll run default debugging. So that's the file that sets that. Now, Ccache is the general caching file that actually does all the caching for modules that are cached. So it's the guy who controls how we do caching on LuCI files in general. CBI.lua we've talked about. This is the CBI controller. It translates any CBI page that has been called from a controller into an HTML file and then passes that to the browser. And then we went through Ccache. Config.lua reads the LuCI config file, just the LuCI config file. It is not the generic UCI file loader. It is the reader for the LuCI UCI file to just check what's in there. Debug.lua is the debugging commands. So, for instance, when cache on demand is run, it runs debug.lua with the S value and one level of introspection. If you click on this link, I have Lua's getinfo function, like the actual definition for it right there, so you can go into more depth about why the S value is important, and when we do later, like how we do like line-by-line stack trace, why that matters, and how that works, and why we're passing what variables. Not really important for right now. It's like pretty in the weeds, but it's a cool link. Just click on it if you're interested in further debugging, and like why it's debugging in the way it is debugging. The Lua debugging suite is kind of interesting in general because it's only primitives, and so when you build a debugger, you have to build it yourself. So next is the dispatcher. So the dispatcher is what CBI passes its final pages to, but it does HTTP requests, page loading. It controls all dispatching of the trees of HTML pages. It's when you receive, when an index error happens, when you haven't put an index in right, or you haven't put a parent, because the dispatcher is actually a tree-based system. Do this in front of the camera, of nodes. And you set it so oh, this is a, it's the admin / pineapple / commotion, but you haven't created pineapple. Dispatcher is where that error is going to happen. So you'll see a lot of errors in dispatcher that are because you badly formatted your index code. So if you see dispatcher erroring out, the first thing you want to check is your index and the entries there. And then, I mean, pretty much that's what's going to be. Something's wrong there in your entries or index if you see a dispatcher error. Next is fs.lua, which is just the Lua file system library. So this contains, this is actually one of those like really useful function or sets of functions. It contains things like, oh, give me all the entries in a specific directory. Give me the directory name. Tell me if this path exists and if it points to a directory. Remove a given file from the directory. Create a new directory. Retrieve a symlink. You know, give me the last modification time of a file in Unix time. Set the permissions on a given library or directory. So, yeah, the file system library is really useful, and all those functions are contained in fs.lua. HTTP client.lua it's client-side implementations of HTTP standards like GET requests and cookies. And it's very small. I don't think you'll be using it directly much. What you'll most likely be using is the HTTP.lua libraries, which are a much more robust library of all of the different HTTP functions you're going to need, like write, splice, get environment, get cookie, close a connection, build a query string, and it also has these submodules around protocols. So like URL decode and parse message header, and then if, and you know, all sorts of crazy fun protocol implementations for like convert the given Unix epoch time to valid HTTP date string. Really useful for more nitty-gritty networking stuff. A lot of your stuff's going to be living just in the generic HTTP library. I mean, I don't know what you're doing, so maybe you're going to need it. Go you. I18n.lua, nickname Chris, is the LuCI translation library. No, so this library, it's cool for a bunch of reasons. One is that when the files are being parsed, your template files, your CBI files, and actually, yeah, so when files are being parsed to be produced into HTTP, this library finds any file that's been defined as or any string that's been defined as translatable, and then checks the language that it's originally in, like the system was in originally, checks for a translation file of the given, checks all translation files for that string. So even if it used to be that you had to define a translation file per page. It's really annoying. Now what this does is goes through all the translation files, and if you use the term node and you didn't translate node, but someone else used node in a different translation file, it keeps all those translation files active and will still be able to translate the term on that page. So you don't have to have node 100 times for each page that you load. It's just one giant blob, so you can have 30 translation files for Spanish, for different pages, for different modules, and this will go through all of them to try to match to the string.
What's the precedence if there's a disagreement?
I've never seen it. We should try it. We should break it.
What is
Go ahead.
It's probably the last loaded.
what do the translation pages correspond to then?
So a lot of this is legacy. So there are a lot of like the translation files actually. So they're essentially a set of like this word to this translation and you do it for every language. So like there'll be for instance, commotion.es, commotion.fr, and right now we have commotion.fr for the French translation. And the legacy was that you did it for every page. What this allows is that every module actually has its set of translation files that it pulls in. So there's a bunch of them because each module only has its own translations in it when you load it.
So it's like one module, one translation file?
Exactly. So that way LuCI doesn't have to contain all the strings that we're going to use. We can have our own translation file and just throw it in the translations folder. And if one of our strings appears, LuCI will go, oh, hey, that's in the format with a .fr at the end. That's probably a translation file. Let me check. Oh, it is, because it's also compiled into a hashed format. So it's like a binary kind of, or it is a binary format. And then it goes, oh, yeah, hey, there's that word I'm looking for, and there's a translation for it. I can use this and put it into my library of translations.
For efficiency's sake, are there any best practices for like keeping language consistent across, across files, and like trying to reuse the same sentences consistently as possible, or does it translate on a per word basis and it just doesn't matter?
No, it's full string. So if you have a comma out of place, you need a new translation for that string. So for headers, like headings on things, yeah, something like node would be really useful. Also probably for like illustrations, or like where you have like the, that text in the, rollover, and for people who are blind text. Probably those smaller chunks of language would be really helpful, but it is on a exact per string format because it is hashed. So they're actually like checking the hash against the words.
I was just going to say that though you don't have to have a page-per-page translation, like this page has these files, when you write the page, the strings that you want translated have to be either, if it's a template or an HTML page, it has to be in the like percent brackets, and then if it's a code file with code, you have to use the ITIN function.
Yeah.
That's what I was wondering. How is it now?
Yeah.
Right.
So
And
any
then-
code uses the ITN function, and,
And so each string per string, like if you have sentence 1, paragraph 2, the way that it parses those out is that this, heading node is one thing that gets translated, and then this paragraph is another thing. It's not like you go through a paragraph of text and have each word encompassed with multiple braces.
yeah, because you need the context for the translators. Now we could do like multiple parens for a paragraph, for instance. If we had some stock language that we use in a lot of pages, we could make that separate. But when the translator sees it, the way the translator sees it is just that sentence. And so out of context, and so we want to keep as much context as we can in larger paragraphs, just, for the translator's sake at least. And so there is a format, and it's part of IATNN, that actually will go through all of your files and produce you, it's called a PO file, I believe, which is just like the generic, like here's all your words. And we'll be, I won't do it today because I didn't get to it, but we'll be doing later, we'll be actually automating that process for our build tree so that it pulls out all the translatable files and checks them against their current translations and sees if there are any changes, and then allows us to really easily, or even hopefully automatedly, add them up to be translated later, so that our translated user base, not user base, like the what are they called, transifex? Transifex is automatically done as the new builds are made with translatable strings. And again, strings have to be defined as translatable through the syntax of either being put in the translate function, like as the variable to a translate function in Lua code, or in the special syntax, which we'll go over later for strings in templates. Then there's init.lua, and this is essentially just the main LuCI initialization module. It's really short. You won't ever deal with it. I almost guarantee it, but it's there. IP.lua is LuCI's IP calculation library, and so that's right here. So, give it a hexacoded value to get a LuCI IP CIDR instance of a specified address family. I've never used it, but it looks like it would be useful things.
It may not seem useful, but it is.
I'm sure it's totally useful, but I've never had to use it.
Those are awesome.
Convert given long value to network byte order in little endian hosts. Really cool utility functions. Nixio also has a lot of tools like this, in the probably not the socket library, but anyways, we'll keep going. JSON.lua is LuCI's JSON library. So when you're playing with JSON, taking in JSON, removing JSON, when our Commotion D profiles are in JSON format, we'll be using the JSON library to do that work. JSON-RPC.lua is an RPC, remote procedure call library, that uses JSON. I couldn't find much documentation on it, but it looks like subsignal.org has the original JSON RPC, the non-OpenWRT version on there. So I haven't yet had a chance to compare the two code bases. They're both written in Lua though, so I assume that they're probably at least very similar, though the developer is different than Jao, so I have to check who. Anyways, LTN12 is not internationalization. It has an L at the front of it. It's the Lua socket toolkit. So LTN12 is the Lua socket toolkit.
Latin 12? What?
Yeah, well, sockets are Latin. It's a well-known fact. So this actually this this library is what you do when you're doing things like uploading and downloading files to the node. It has 3 parts to it, or 4, 5, whatever it is, which is filters, sources, sinks, and pumps. So you can have a bunch of filters for the socket that you are running, pump data in, make a sink. I learned all this once when I had to make my first uploader, and I've forgotten it all since then. But you know, create a file source, turn a fancy source into a simple source because we're not, you know, classy here, and things like that.
But that would be different. That would be different than just using a file uploader from the HTTP web, right? That looks like code I've never seen before.
That's I mean,
just doing simple file uploads from an HTML form.
So let's go to file uploader. I believe set file handler uses it in its code.
Okay, so somewhere else it's being used.
Because I tried to build one from scratch for fun, and I had to use all that
that
stuff.
makes sense. Yes.
But I believe set file handler, when you look at the set file handler code, which is the function we use for uploading, it has that in it. Lucid.lua is this really cool library I didn't really know existed until I was doing this work, which is a superprocess, child process, and daemon manager in Lua. So that you can work with RPC. So it is used in RPC, HTTP, and other networking services quite a bit, it looks like, by the LuCI developers. It looks really interesting. I haven't dug into it very deeply. I just, when I was going over the code, I found it and explored the API a bit, and then explored the source code. Looks really cool for managing multiple processes in Lua, which is really hard. And we've had, me and Dan sat down and fought with how do we get sub-processes to work correctly with Quick Start when I was...
Oh, yeah.
Remember that? Yeah. That was a horrible day that if I had known about, if I'd actually read the Lucid API, it would have been interesting. NIU lib is essentially a short library that gives you the list of available and in the case of Ethernet, bridged interfaces for wireless and Ethernet. It looks like it was probably a helper library that they built a while ago. It's pretty clean code, too, for dealing with UCI files and comparing those against system variables. So if you're looking for a good example of clean code about how do you work with UCI, and it uses the LuCI UCI library, I would definitely check it out.
Does it look like that's on the routers? Do you know where to find that?
Maybe NUI lab.
It's not on the routers.
It's not on the routers? See, it should be in the dev environment, though. I think I pulled it from current LuCI trunk, so maybe it's a new set of functions. I'm sorry, yeah, but it's definitely in current LuCI trunk. Because I was running off my development environment, which is the current LuCI stack. RPCC.lua is the LuCI RPC client, remote procedure call. We went over SOF already, which is we talked about the UCI file, but this is the actual code that runs those user sessions. If we decide to ever add in multiple users with different privileges, we'll have to do a little bit of stuff in this file. And it's already been worked out by Zhao. I don't have the link here, and I wish I had put that. Or it's been worked out on the LuCI listserv. I don't know if Zhao was involved in the conversation, but I read that. I read the example code of how to get multiple users working with LuCI. Store.lua is essentially just util.thread local. It's just them running util.thread local, which is weird, but okay. That's what that does. And by the way, I put the actual API for thread local so you can see what store.lua is doing. At this point, when I was, this is one of the last things I did, so I wasn't really going to go dig into why store.lua exists and what it was being called by. Sys.lua is the LuCI Linux and POSIX system utils library. It's awesome. So, for instance, call, which calls a function, really useful. You should Nixio's execute function command, on the other hand, though, actually does proper commenting on the function. It actually if you send it a bad value, like for instance multiple functions chained together, it will call those. It'll call it as one or throw an error. It'll say like this is not a proper function. This is a lot of stuff going on, and you need to call it separately. LuCI's call is a much like basically just like pipes it to bash, and runs it. And I can get you guys a link if you're interested, or if there's a tips on how to search for these things. You can use some of those tips to find the actual like why Nixio's library for calling functions is better than LuCI's. So I would check that out. But yeah, it has things like get the output of dmessage, or get log read, that sort of stuff, which is really useful functions in luci.sys. I should have put this later in the thing because this is a really boring section, like the API. Template.lua is the direct parser for template files, which we'll go over, because there are CBI files, which are the UCI interface for creating pages out of UCI files. Templates are actually a secondary form of views that allow you to use both CBI and LuCI and pre-built HTML and JavaScript to build cool pages. And they can use Lua code blocks and more.
Is that the right way to do views?
No. So they're both correct. CBI creates its own view out of the model using the generic CBI view. So they have a generic view, and the CBI pulls the CBI model and applies the generic view to it. Templates allow you to do custom views. So CBI can do most of what templating can do.
Okay.
Templating is just like...
I didn't mean right correct. I just
Oh.
right as in you should do it this way.
So actually, no,
Oh.
they're both correct, because, for instance, the reboot function uses a template because there's no reboot UCI value. But if there is a UCI file for what you're trying to manipulate, that you should always use UCI and the init scripts, because those know better than you than writing your own functions in a template with a controller to do the stuff you need to do. If there aren't UCI files and an init script that does what you need to do, like for most of the Commotion stuff, we don't have those in place for many reasons. So we write a lot of templates with custom scripts to go out and do stuff on the router, because the things we have aren't UCI controlled or are, otherwise not CBI compatible. CBI is simply for the UCI components. So they're both correct. Yes. And then util.lua, we already talked about a little bit. It's the utilities functions. So a whole bunch of cool stuff. For instance, exec also. So call gives you call right here will only return the error code. Completed or didn't. Exec will give you whatever gets outputted by the function you execute. So, yeah, it has other cool things.
And just on that note, if you're using call and doing a shell command that will produce output, instead of, it will basically replace the page, the web page.
Oh, yeah.
And not allow you to send your own web page. So it will basically just give the user the output of that command. So it kind of screws up the web interface a little bit.
And they use that effectively in an iframe when you're on the debugging menu, I believe. So they can output directly the output of like ping and traceroute. It's a pretty innovative little thing they do there. There's also exec_I, which is like a line buffered iterator. So it like gives you all the command output line by line. There's some cool stuff in here, and they're like, the more you read them, the more you realize how bad your old code was, or at least for me. And then finally, there's version.lua, which just gets the current version of LuCI and Lua and returns them, among a couple other things. But don't touch that file. That's not cool. They're nice things. You don't need to ruin that. So as I said, and I'm just going to go really quickly about Nixio. Let me go to the index here. Yeah, so Nixio has a lot of the low-level manipulation primitives that are used in LuCI. If a LuCI command like call is doing something you hate, and there isn't an alternative like exec or exec_I, you can almost always look to the Nixio library for the primitives you need to build it without having to drop down to LuCI's I/O library or LuCI's based networking libraries. Because, why re-implement what's already there and been written by people who know what they're doing, especially with these functions. So I highly recommend reading through the Nixio API docs just to get an idea of what they're doing. And then if you find the Nixio API command that you think you need to use, grep in the LuCI directory recursively for that command. Because there might be a LuCI command that does what you need to, you just didn't find it. And also later I'll tell you, like my favorite Google search over these APIs, like you define this site and the thing that you want to do in the most generic term, and a lot of times you'll find a function that seems like it's in the totally wrong library. Like Nixio.bin happens to have a socket function, or something ridiculous like that. And it's great for finding the functionality you need that you thought you would implement yourself.
So those are available and on the node, or are you saying we should look at those for...
These are all available and on the node.
Okay.
Yeah, these are all implemented on the node. And more, actually, there's a couple unlisted functions. Because this is only if they did their own Doxygen documentation.
Oh, okay.
So if you go through a lot of those files, there's a lot of functions that don't have
Nice.
Doxygen commenting, and you can find them that way,
Cool.
which is really annoying. Oh, you're good?
Yeah.
Okay, so let's start talking about the controller file. So, as I said, LuCI is a model view controller system. And so if you guys go to the example folder, and is it example and guide? Just example folder. I changed it. Yeah, so if you go into examples and get the empty controller.lua and guide controller.lua, those are going to look, that's a view, here we go, like this. This is an example of a very, very simple controller file. All the controller files in Lua are actually modules, and they're going to be called as such when they're processed. What we're doing here is giving the path from the original LuCI module. So this is actually LuCI-controller-test is where this is looking. And the reason for this is when you look at the Lua path, it should have been in the Lua tutorial. Anyways, the way Lua paths work, and actually you can, and if you go to the Lua tutorials, it's in there. I just probably missed it. This is going from the Lua directory, and then it's looking for a .lua function or file that is LuCI.lua with these inside that module. Does not find it. So it goes, okay, great. So I'll go to the LuCI folder then, and then check for a controller.lua file that might have a test function in it. There's no controller.lua in the LuCI folder. There is a controller file though. Then it goes, adds another dash and goes, I'll look for a test.lua, and test.lua is there. Which is why this file has to be in the LuCI controller test, LuCI controller, and then named test. So this will extend out to wherever you need to be on userlib lua LuCI controller test.lua, as it says here. So that's what this is. This is why your module has to, it'll give you errors, the dispatcher will give you errors saying, I can't find that controller because your file's not there. And then it says, let me see all the other packages, so you can call all the LuCI functions and the like. And then, again, the dispatcher controls this function, which is required, called the index. Even if you don't want to use an index, if you just want to make a controller function that's used by other controller functions, you have to put an index in there, because the dispatcher looks through all the LuCI directories for controller files, and will actually check to run it, and be like, well, I don't care if you just want this Lua file to live in the LuCI controller directory. If you want a file that's not a controller for these pages, put it somewhere else. But you can fool it by just putting an empty index in, and it doesn't care. It just won't load any pages. Within the index, there is, in each index, an entry. Now, the entry has a few parts. And let me actually jump over real quick to the guide. And all this, by the way, can be found on the LuCI site. They go through this in pretty good depth in the modules section. Each entry has a path, then a target, then a title, which doesn't have to be there, and an order, which doesn't have to be there. And then after it, there's also a series of like other commands, which we're not going to go that deep into. You can, again, go to the modules tutorial and documentation on the LuCI site to go deep into that. So what we're doing here is we're setting the path to admin view test. Now this will actually mean that when we go to the node and we go to the IP address slash LuCI slash CGI dash bin slash admin slash view test, then this will be run, whatever the command is, the actual like target. And there are three types of targets. There's template, which runs with the templating engine, the template that exists in userlib lua LuCI, view example view reboot.htm, and that's how template works. And so that is for pages that don't have a UCI, config that they're pulling from. Template will call those from the view folder. And then, actually I'll just go through all these. Call, on the other hand, unlike template, will call within this function a function, or call within this module a function. So in this case I have call main, and down here I have a function main that it will call. And then finally CBI, which will go into the userlib lua LuCI model slash CBI slash whatever this string is, .lua file, process that CBI, and send it to the user. So both template and CBI will just run what they find in that directory and send it to the user. Call will allow you to actually run some functions. Now in this, what I do is I make a variable go, which is LuCI HTTP redirect, and then I just go to the CBI page. Or actually I go to a page that doesn't exist, because it was the guide originally. But like what it essentially is doing here is just going to this page, because I just needed a function that would do nothing. But so you could do stuff here, and then still go to a CBI. Like when you go to this page, run some functions to make sure they're admin, which are actually run automatically just by having the root of admin. That's actually where sysoff starts running from, and we'll go into how you actually add admin privileges without having that root later. So I will, and then Dan.
So if I do a template or a CBI, do those templates have access to any variables? Or are they just able to just print out static HTML?
Templates can have Lua code within them.
Okay.
And so that Lua code can call functions from the LuCI libraries and the like.
But, okay, and so if I want to seed that template with special variables like...
You got to go to main.
I would have to call a function in this file that would set up some variables and then include the template or exactly the template.
Yeah. Dan, I'm correct on this, right?
Yeah, that's actually exactly what I was going to say. Is that's what I use the functions for. Is I would process some like get or post parameters or something, and then call the template with some variables.
That's what I was wondering. Okay, great. And how is that different than? How is the template different than CBI then?
Well, let's go look at some templates and
Let's
see
do
what you
it.
guys. When I'm done with this section, you can.
Sorry.
No, I'm kidding. So here is a template. It's HTML. This is all comments. And also, per the controller, it has to live here. Because that's where I defined it. Remember, example view reboot. It has to live in the view. That's how it gets called. I run a function on it first, where I require Commotion helpers, and then run the check HTTPS function from Commotion helpers. So it's just straight Lua code running here. And then this is HTML with a couple other pieces of Lua code. For instance, this one starts an optional section. It goes, give me the UCI, check if there are any changes to be set. That's what's going on right here, by the way. It's make a variable C, require LuCI model UCI, the cursor function within UCI, and then run in that cursor function changes. That puts in local variable C. So what's actually happening here is saying, give me a UCI cursor for the UC, the in the LuCI.model UCI function. That cursor will check for any changes that need to be set. If you've clicked save on a bunch of pages, it keeps track of all those things that haven't been applied, and put it in C. Now this returns an array. So we then check if C is there, and then run next C. And what next C actually does is iterates through an array to the next item. If there's only one item in an array, or there's no items in an array, or it cannot iterate to the next, it returns null, which is a false value. So if C exists and there's nothing else in C, it's not an array of values, which is what next C does. It checks to see if there's another value next. And if not, it gives you null back. So does it exist? And are there multiple items in it? Then run this set of code until the next end statement. And this code is actually a warning there are unsaved changes. So that won't show if there aren't unsaved changes. Because it checks, it makes a cursor to check for changes, make sure that that cursor exists, and also there's items in that cursor. And if all that things happen, it then gives you this HTML. So that's what the template parser is actually doing, is running through this code, and any blocks of HTML that are allowed aren't in between code blocks that say, like, don't show this or do show this. It'll appear. And then it starts again, and then if not reboot, and then it'll give you more code down here.
And so this is what Dan was saying when he sets up his variables before he invokes the template. Then in there, I would have, like, instead of local C, I would just be able to access my variable.
Mm-hmm. And when you use that, when you use the call function, you actually say, pass it this variable with this as this name, and this variable as this name, and this array as this name.
And like another example of that is that when I set up the local apps page, there's an admin version and a non-admin version. And so I would call it, if it was the admin page, they'd access it through the admin path. I would pass the variable admin, and it would just enable certain sections that would be visible if you didn't pass the admin variable.
And then there are special values. These are the template values, and they're coming up in a later section. We jumped ahead a little bit. And so these are things that get automatically filled in if you use them, and they use the percentage plus sign for the template to read them and say, oh, percentage plus footer, that's one of these special values. Well, footer is an HTML file that lives in userlib lua lucy view themes, current theme name, footer.htm, and just drop that right in here. And the same up here with header, which is that guy right there. So our header and footer are on every page and loaded that way. If we don't want to show our header or footer, like Quick Start used to remove the header because I didn't want people going to the admin page, like the first version. And so I just didn't give them a header unless they had gotten through a certain amount of sections of Quick Start, and then I give them the header back.
And do those pages go through the interpreter also? Are they?
Yeah, those go through the interpreter as well.
So those.
Yeah, currently our header actually runs this check HTTPS function. So any page that loads the header, if it's an admin page, and that's how this function works, goes, if it's in the admin route, force a redirect to the HTTPS version if they're on HTTP, which is kind of cool, in my opinion. So any page that uses a header, if it's an admin page, gets automatically redirected and that way we don't have to change to every page to add that redirect. We just threw it in the header because it gets parsed through the template system. So we're done with that, and we are on controllers now. So as we were talking about controllers and damn it, see, this was all pretty, but I didn't put enough spaces in front of that first X, so it's all not pretty now. It sucks. We're just going to go to the actual file because it looks ugly here. Well, it's hard to read. So Lucy tutorials, tutor. So to enable authentication on a node where you aren't using the admin path, because remember how I said that if you have admin in your path, you're automatically required to check for authorization. You can set your entry to a variable. And then one, you say dependent equals false. Dependent is a value. You can actually do your entry dot dependent equals false, and that means that it depends on all the nodes above it in the path. If it's dependent by default, a node page is dependent upon all the other nodes above it because they form a tree-like structure, and each entry is a leaf. And so if you have an entry that is my app, comma, pineapple, but there's no my app entry defined, it will break. It'll say, there's no my app. I can't give you my app/pineapple because I don't know the requirements of my app, because these dependencies, actually they're like, essentially you can have cascading dependencies, such as sysauth, which is cascading from the admin root. If you're after the admin root and you're a node off of that, you require the privileges of the admin, of sysadmin, which is required on admin. By putting that dependent equals false, or you must put dependent equals false, and then change sysauth to equal whatever authorization they require. So this is actually also one of those things you can change if you want to have alternate menus that are admin only for different users than root. Currently, everyone just uses root because it's only used on the nodes. But if you wanted to have a user that was like maintainer but didn't have root access but could change certain variables because you wanted to have a different community model about who can update what aspects of the node, you could do that with users and permissions. And this is where you'd set that secondary menu for them. And then xsysauth authenticator is HTML auth. And that's just the authenticator we use. Now, what if we not only wanted we didn't want admin to be the root node, which it is currently. We wanted our module page to be the main root node for the menus, so essentially a new menu structure itself. We could change the root node to equal my app. The problem is, of course, the name of your app has to be greater than admin due to alphabetical sorting. And I don't remember why this is useful now that I've been talking all day. There's a reason this is really useful.
Well,
Dan.
we used it at AMC and where else did we do it? And in Berlin to set the root node to be the apps portal instead of the normal root page that we have.
Yes, that's why. That's why this is useful, people. Listen to Dan. Thank you, Dan.
So we'll remember that after we go through the UI review and want the landing page to do something.
Yeah.
If we have x.sysauth, that's really hard to say. Sysauth sets a root. That means when and then I use the sysauth authenticator, that's going to check the system to see if there's a root user in it. Password matches. That's great. What if I want multiple users to have access to that page? Like, what if I want root and somebody else to have access? Can you do that? Or is
You
it
can.
Okay.
It is.
Just do a different thing.
Yeah, there's actually to have multiple users on a node, there is a larger process that has to go through, especially for LuCI compatibility, for setting all that stuff up. There's documentation out there.
Probably not their big use case because they don't work.
Yeah, there's a few people whove done it, and so that's where the documentation comes from, and it's only changing a couple places. Okay. But it can totally be done.
Great.
Yeah.
Thanks.
So back to the prettiness. We've done, that was 3, right? Yeah, so we finished the controller. And that was a very brief overview of a controller file. When we go into solving a problem ourselves, we're going to go into a CBI file, and we're also probably going to look at a controller file as well to do a more in-depth dive. I just want to give everyone an overview before we get into that. So CBI, it's called CBI Basics, but this is not. Or no, maybe, is this CBI Basics and there's CBI Advanced? Did I do that? No. Yeah, this is not CBI Basics. It gets pretty in-depth.
Seamus, what does CBI stand
Yeah.
for?
I have no clue. I looked all day yesterday.
I've been Googling it and Wikipedia cannot find it. Yeah. CBI, I have no idea what it stands for.
You have no idea.
Okay.
But it's one of the coolest features of Lua. It's the uber coolest, sorry, the uber coolest features of LuCI. So, oh God, I hate this stuff so much. This is a CBI file. A CBI file is a map. It takes a UCI file, it creates an object out of that UCI file, and then it utilizes a special syntax in order to translate that CBI file into HTML. I'm going to walk you through this example right here. This is directly stolen from the LuCI site and their CBI tutorial because I did not want to write a new CBI file for this lesson. So the first thing we do is we set a value m equal to map, which is a CBI function for taking the network, sorry, the network UCI file, and naming it network with a capital. Because that's really useful in a tutorial, is naming the exact same thing as the thing we're accessing. Sorry, I'm not going to complain the whole time we do this. Then we set a value s equal to m section. Now the map has a series of sub-functions. Essentially, it has a metatable of a series of functions for dealing with UCI files. So we run the section function.
So the map is basically our page, right?
The map is the UCI file.
The map is the UCI file.
So you can set multiple maps, like map 1, map 2, map 3, for different UCI pages, UCI files, to create a more complex page with, like, for instance, the wireless page has like some networking stuff and some wireless stuff, and so you could have multiple CBI files running. The map is just it's the controller for translating CBI into HTML. So for instance, map.section, like the section function there, creates a type of section. In this case, they use the value typed section, and there are a few different types of sections you can give it. And there's the CBI documentation, which we can look at in a second. We'll go in a lot more depth about how you pass variables to this. Actually, let's do that first so people can follow along if they want to. This is the where am I? Oh, I'm on that page. It was a link I clicked. Awesome. Documentation, and then CBI. Is it CBI? Yeah. So again, each of these, the map is actually like a root object that you can call with the config, the title you want to give it, and also a description for that title. These will be translated directly through the CBI view into like the pretty like top level menu that says, I am this thing with this value and blah blah blah. So when you call maps and you return, like, so when you return a map to the page, you're returning one of the maps with the header of that map. So, for instance, the Wi-Fi page, you create 2 maps. It has 2 sections. If you create one map, you create 2 maps and then pass a section from the first map to the second map, you can have network sections within the wireless map that's mapped to the wireless CBI file. It's not the most intuitive thing in the world, obviously, but essentially it creates a class object for sections within that map, and you can pass back multiple maps to layer different sections, but in order to integrate sections together, it becomes or integrate UCI files together, it becomes very complex very quickly, which is another reason why I use templates almost entirely over CBI. But I do believe that as we get really well parsed UCI files for a lot of our, like, you know, for instance, the application portal has a really solid UCI file, and we start doing that for a lot more of our functions, we should be moving more to CBI, because then we can just work on the init scripts that handle those UCI files. So, you know, when we save and apply, it'll pop off an init script that we can write in Bash or in C that will then manipulate the program, like our modules, based upon those files, and do less of that in the Lua interface, in the controller files. Because then also it doesn't rely on the browser so much. The user interacting with the browser, and you get those delays that we get, where it actually gives you that like one-line error. That's like what is the error? That one line at the top that shows up. It's like the delayed, no response, like we received no
Oh,
response.
CGI bit, yeah, did not produce any response.
That's because the Lua script is taking too long to process the data. So by using an init script instead, we apply to the UCI file, and then the init script runs, and you get the next page. So the user doesn't have to worry about, our user won't experience that because it's not running in the browser. It's not delaying the response time of the browser. So why CBI can be really useful. But it is, obviously, by my just intense frustration before I even started, a very frustrating toolkit. So anyways, so then we create a section, a typed section in this case, using the network file section interface titled interfaces. And this will show up as a section in like an HTML section. Then we go s.addRemove equals true, which means that you can actually add and remove objects or these sections. So by setting the variable to s and then changing addRemove, which is a property of a section, to true, we say if a user uses the checkbox to unclick this, when we hit save and apply, we will delete that section. And so a lot of these CBI functions, for instance, let's go down to type section really quick, have a lot of options on how you manipulate UCI files. So add remove is the ability to add and remove a config section. Dynamic means that it can contain an undefined number of completely user-defined options, so they can just add as much stuff as they want. For instance, if we were doing the apps portal, we might say like, oh, if they want to create another section like my favorite color, they could do that. Not that we'd ever do that with apps portal, but you could offer those options if your UCI file had room for like, oh, this is a user profile. Add whatever information you want in my module. Dynamic could be one of those options. Optional is a way to set certain sections or options within a section as optional. Anonymous is where it doesn't actually tell you the section's name. For instance, if you don't want them to have to deal with the gobbledygook names that are automatically given, or for instance, you just don't want them to see the name in general when you pass to the user. Again, these are admin pages usually, so hiding information from the admins is not exactly the most useful thing, but there's an option for it. So there was also a depends section. So you can link certain options or sections to other options or sections. Filter, which allows you to not parse certain sections, so like basically filter them out. And then option just creates a whole new parameter to put in that UCI file. And this is just the typed section, which we're using in this example. Now, typed section also has a specific format for viewing in the HTML. And this is where CBI is a view as well as a model. It's essentially a connected model view. Because typed section versus a named section versus, well, values an object. Yeah, so typed and named section are two ways to show a user a section of content. And they have certain options to go along with them. And a lot of the options are the same because they're generic. But they also are seen differently. And we're going to go into a node in a little bit and look at some different sections and look at the CBI code that goes with them. And so what they're doing here, one is they're running a filter so that if it's not loopback and it exists, then show interfaces that are static and show interfaces that are DHCP. So don't show the loopback, but show all other static or DHCP protocols. And so then it automatically parses through those sections that are interface sections and places them on the page. So you don't have to define, now show me to this one, and show me to this one, show me to this one. Just like any static or DHCP interfaces that aren't loopback, populate them on the screen and let the user manipulate them as such. And through the data types, which, well, I defined some, oh, I think I defined in the last section. And through the data types, it actually, you can qualify how these things should be interacted with. So how the actual options should be. And so, option, list value, protocol. When we actually look at best flag, where's option? List option, oh, they don't have it here because they hate us. Well, let's just look at list value. Which is the way the option should be shown and what functions the option has. So for instance, you can add an entry, only show this if another, depends. You can use a different form widget. There's a bunch of different little widgets they've made in the view that you can have this look like. You can say the size of the form field so that, I want it to be a long, little tiny form field. Can or cannot be an empty value, can be optional, and so on and so forth. So as you move through your CBI file, you're not only defining the sections, what's shown in the section, and through these, through this option, how the section looks, you're also going for each individual options. And again, we depended on proto options. So for the proto options, you're naming them protocols. You're using the list value view for them. And then you are offering these values. So the static value is the static value, the DHCP value is the DHCP value, and the default is static if there's not a value set. And then it goes through here and goes, give me another value for interface name interfaces. And it's a simple text box for interfaces. And this one's in German or something. No, probably French. I don't know. Give me another value for IP address, and use the translate function to make this value translatable. Oh, which is why he used the different language. He's so funny.
So this is an I-89 function.
Yeah. Oh, is that what it says?
Yeah.
Nice. So yeah, so that he's using the translate function to say, also, if we have these words, translate them into another language. Then he does the same. He says, now give me the option netmask, and that depends that the protocol is static. Of course, we know the protocol is static. This whole section has to be static because the whole section depends on protocol static. Is it me or is it the syntax?
Oh no, the CBI. It's just very...
Yeah.
When did you get to the hard stuff?
About 10 minutes ago.
Yeah.
And so this is basic CBI. Now let's dig into complex CBI. So first, let's look at just a simple filter, right? And you're going to use this if you're using CBI a lot. So we create a map that is network, the network file, and give it a title and a description. We use a section as a type section of interface. And then we run a function, s.filter, from a section filter on itself. Do we put section here? I think we keep section. Oh no, we give it the section title that we care about. And then we return the section map of only those where the protocol does not equal GRE.
Could you show us maybe on the last example what that output actually looks like on a page?
On like the page?
Could you ever just at least like describe what it specifically would show?
I see. I've avoided CBI like the plague, but I think self section, section proto, because section is already defined. Yeah, I wonder.
It's all just a basic set of controls, like
Yeah.
drop-down menu or box, whatever.
Yeah.
Yeah.
Let me log into this node real quick. I have it set up to do some stuff, and we can look at some code along with the pages that go along with it.
Yeah, it basically generates the page, and I mean,
Yeah.
it's a really it's good at being a systematic way of developing an interface just based on the value. I mean, that's great for an NPC. That you just here's the data, here's the model, and there's an automatic way to generate the view, but it kind of limits the type of user interface you can design, which is one of the reasons that I didn't use CBI for the apps portals. That I wanted to design a user interface, and I didn't do that with these limited set of widgets.
Yeah.
Right.
Now you can modify the template CBI uses to actually the CBI HTML it generates. It's a ton of work for what I believe is. I think it's too much work for the output we're looking for, because then you have to make sure that the old pages don't break with your new.
It's very the way it feels like old interface coding where you have the interface being spit out by higher level code instead of PHP where it's
Yeah, I feel
It's like the old way.
yeah, it seems like a good way to generate like an administrative interface or like a node administrator based on like all these different configuration parameters for a router. But for something that we want to do that's user facing and user facing,
Yeah.
it doesn't seem to
We
make sense.
we don't really want to vomit the database on the screen for the user. But for an admin, when because all the menus are based upon the structure of UCI files and where they fit. And so it makes total sense if I know the UCI files in and out and I understand why they're organized the way they are. It's an awesome system because it's just like being in the node. Yeah. Versus if you're a user and you don't know why there's a system and a status section that have the same things in them, it doesn't have that intuitiveness. So great. So we've got some filters. Awesome. Let us look at VLAN. Is that a good one? I think VLAN's the only one. Oh, iFaces is using it. Great. So, let's go down to this filter. So you'll notice that they're inputting Lua and CBI here to determine CBI values. So by using Lua code interchanged with CBI, like if there is a switch, if a protocol switch was requested, rebuild the interface config and reload the page. So you can use them interchangeably. A CBI file is a Lua file. So you can have complex CBI pages that aren't entirely based off of a generic CBI template. You can come through, Lindsay.
Okay.
You're just going to be on camera. You have to smile, though, when you walk by. No, to the camera. You just got it. Okay.
That was my quick walking.
But no, so this allows you to make more complex kind of enmeshments of CBI pages. But it doesn't, again, not the full fun that we'd want. So let us look for where they actually have that filter in here. Actually, we can just do this. Admin network, iFaces, and we'll go B10, A10. Okay, so here is that filter, s.filter self section, and it's living. Oh crap! I didn't go high enough up, but it's living near the DHCP server section. That's going to be titled DHCP server when we look at it in a second, and it's saying get from UCI DHCP section interface arg1. So from the second map 2 they're using in this file, get any arguments that equal argument 1. Argument is defined, and what line is this on?
No food for you.
So we want, is it O that just gives us a line? No, it just gives us the single word, stupid thing. Anyways, I should have prepared. Oh, I didn't know we were going to talk about filter. Here we go. So this is our DNS masks section. It creates a map of the DHCP network or config file. It then sets has section to false initially. It runs for each, which iterates over the DHCP file in a section, each section called DHCP, running the function, the anonymous function behind it, function S, that checks if there is an interface, because S is what we are passing, this higher order function, if there is an interface that equals argument 1, and argument 1 is defined somewhere up here. Yes, argument 1 equals argument 1, or quotes, thanks.
Yeah, so it's
Friggin'
like the first argument, right?
Yeah, whatever it's being passed.
Yeah.
But argument is being defined. So it used to be that when you passed an ellipse, it was put in a default table called argument. That's no longer the case. So I don't know where called arg right there. I don't know where arg is, but I'm assuming right now it is nothing, or it's a nil value.
Arg1 is like an argument vector in C.
Yes, but that doesn't exist in Lua anymore.
Oh, really?
Not by default. No, they removed it. Anyway, so this is essentially, so what it's doing is it's checking for that section. It then says if we find an interface, then we put has section equals true, and then return false. Jump out of that for each loop, and then if we haven't found a section yet, we create this section here. Otherwise, we create this section here and run this filter, M2 UCI. And by the way, M2.UCI is actually calling LuCI.UCI essentially, and then the get. So UCI get from the DHCP the section that we have picked out here, which is DHCP, I believe is the section. Yeah, type section DHCP. So section there, and then get me the interface option and check to see if that equals argument 1. And if it does, give us that. And so that is our filter being run here. The page itself looks like this. I guess we'll use one I already have. Controller. What is it? 102 something?
27.0.0.1.
Oh.
You know what I'm gonna do?
Localhost.
Stupid freaking Chrome. What the? Monkey butter?
Isn't it running on your current machine?
No, I'm running on a node. Okay, so yeah, Chrome's really finicky about the way that you call this node. Firefox less so. So this is my Seamus LuCI test node. And if we go to our Wi-Fi section, wait, was it that Wi-Fi section? Is that where we were? No, admin networking, that's where we were. Sorry. Well, I can actually just look at the file location. So, yeah, so admin network. Okay, so it is the top level network. Come on. Sorry, my alt tab is on my computer and this is here. So this is the page that gets created here.
So it tells you, yeah, this one's a plug, this one's
Mesh. Sec. So if we go back to that code,
and this is all this just directing what the model actually, or sorry, the view actually shows.
so the map interface overview, if we do this, that's not the page we're looking for. Yeah, this isn't, that's correct. Oh, so, sorry, I have to, yeah. Oh, I don't think this is actually that page. What page are we looking at right now? It should be admin network. No, this is this page. Oh wait. Huh. Oh crap. Yeah, I know. That's what I looked for.
That is weird.
Oh, it's not finding it at all. But this is interface overview.
That might be the
No, the B's just look before and look after 2 lines.
That's just, does the B in the A are just when you're grabbing for something, instead of giving you just that line?
Yeah, but I mean the string the string interface overview might not be in the controller.
Let's push that.
Oh yeah, that's not what I want. This. That's really weird because oh,
The interface overview is
unless this is being translated from another language, where the default language is like German, and they're using the translate function to do this, but I don't think it is.
Pull up the password. Unless you wanted to move on.
I would actually love to fucking move on.
Yeah, let's do that.
Let's move on because yeah, I don't translating their CBI. Validating functions. You can validate parameters that are unique or can't be defined using the existing schema by using the validate function. You can define the validate function for an option, and then the value passed is the uncommitted value from the submitted form. So essentially what happens is it checks to make sure the input you're getting is proper, runs validate on it to get that it's proper, and if you actually want, like if it's a good value, you return that value in the validate function. So for the option validate, it goes on submission of a value. If that thing's correct, if it fits whatever format you've assigned, return it back. Otherwise, return back false. Like, so don't set it. Like break. And so you can do the same thing for sections using s.validate. If you name, whatever you name the section, section.validate. You can go through all the values in self.fields. You can call it through self.fields, by the way. So when it's submitted, you check all those fields, run validation on them to see if you want to submit them or not. This allows you to do complex validation of input on the node side. This doesn't save you if you're doing things like load string and they pass you back some craziness. But it is a second layer of validation beyond the client-side validation. Okay, well, this is the part that Dan would actually be interested in. And then also you can...
Just in Cerebro.
Yeah. You can also pass errors back with error message strings to be passed back to individual sections. And so that's how you would pass back a thing that says like, that's totally messed up. We don't accept that thingamajobber, using the .error object for that section or that option, or even that map. The map as a whole. You can do an error at the top of the page or in a section or with an option. And that's all formatted through the existing HTML of a CBI. And you can also do some crazy stuff by using the .parse function. So that goes on parse, do this stuff. And this ellipsis is actually an ellipsis. It's take everything that gets passed back and then run the map.parse function for, and then you actually go, God, this is so confusing. Essentially what you're doing, and you can follow this format if you want to take all the things passed back from a page and run a bunch of crazy functions on them. So if you want to create a simple CBI page that gets data back and then you do a lot of complex processing on, you would use, you would basically hijack the parse function by redefining function m.parse. So it allows you to do a lot more complex parsing of UCI data before setting it to the actual UCI file, which is cool because you can add like extra functions to do like extra pointers. So we could, in fact, do a lot of what we do currently with things like in Quick Start and in modules and in custom templates using CBI files if we had a UCI file and we had to have just a couple extra functions that we ran by stealing m.parse. And this is what I was missing because it's not documented like anywhere until recently, and realized that we could use UCI for a lot of the stuff that we currently have to make custom templates and functions for. save and apply hooks, essentially they look for the, oh sorry, these are not working. There are a bunch of save and apply hooks. There's on a init, which checks before rendering the model itself. There's on parse, which is before writing the config. On before commit, which is before writing to the config. On after commit, which is after writing the config. On before apply, before restarting services, or on after apply, after restarting services. And that's etc config UCI track. Before it runs those is on before apply. After it runs those is on after apply. And on cancel, if you change some things and then cancel out of that form, it can run some cleanup functions. And these are all done by using in the map m dot and then these save and apply hooks to allow you to interact with the CBI file at the different stages of it, manipulating the config, calling out to the UCI track file, running those functions, cleaning up after those functions, or canceling out of a page you've messed with. These are data type options. You can say it's an integer, or Boolean, or string. Here are the types of things that I should be parsing and pushing back to the list. Here is the much loved for each function. When we were talking with Josh, or when I was talking with Josh the other day, and he noted that some functions don't have names, and then we actually went and found their fake names. The way that LuCI handles this is it has a function called for each, which you give it a a config file name, a config file section, and then a function. And you use for each and the function that says hostname equals that section.hostname to get the name of that section. In this case, actually, and then here it's printing out that host name, so you can find the anonymous section's name. This is actually printing out just the host name value of that section. The actual is s open bracket underscore name. Is it underscore name underscore? Andrew, do you remember?
For which?
Oh no, sorry. It's so I apologize. It's s open bracket dot name close bracket, because it's actually a variable. Like, it's a variable you get through for each. And you can also just do get first, which goes through and gives us the first section with that host name. In the LuCI model, you should have cursor for each. I gotta try this. This doesn't look like the right code. Anyways, those anonymous functions, there's a way to get that code. I'll put it in here later. And I'll check these values to give them to you guys. Okay, hitting the wall. Fucking CBI. You can... No. You can use these enable and disabling authentication things in the controller section, accidentally put them here too. Ignore this section. And why is this here? I know why. So you can actually create custom fields within a template. And so these fields right here, and I'm not going to go deep into this because this is something you guys should look at on your own, is using the CBI format in order to create a view within a template, a CBI formatted object in a template itself. And then you use your model down here to pull in the template from CBI. So you can have your own custom, like, essentially view that goes with your CBI model. Which is what we were talking about with Dan, with creating a new template so it doesn't look as ugly as it usually does. Is you do a custom template that goes with your CBI data. And then save versus save and apply. Save just pushes the change to etc config, whatever the config name is. Save and apply also calls the init scripts in UCI track. So just saving it will still change the UCI file, but it won't run the scripts that will actually modify the system. Whereas the UCI command line tool automatically runs the updated scripts. Actually, no, the UCI command file doesn't do that at all.
No.
LuCI does. LuCI has an apply thing that runs the scripts you need to make it work.
Right.
And finally,
But that's a pretty standard thing, change the config file and then restart whatever it is.
yeah. You can also create buttons that run scripts in UCI, or in CBI. Really useful. Didn't know it existed until recently. There it is. Really.
So like, I can put that next to the save and apply button and make it do something.
Like, you know, restart.
Not-
Yeah.
Yeah, okay.
Reboot or whatever you want.
Or run a bunch of scripts and then reboot. Yeah.
Exactly. Oh, Christ. Well, we have views, we have debugging, and then a bunch of example scripts. We're going to pause. Well, no, we'll go through views, and then we'll stop, because I need people here for debugging. It's actually important. Can you press the button? We're going to pause.